So today's lesson is continuing on with inequalities. Now that we know how to graph an inequality and what that open and closed circle means, we need to learn how to solve inequalities. We're going to focus on addition and subtraction today. So the main idea of inequalities, let's zoom in here, is that we are, just like equations, going to get the variable by itself. An inequality is treated the same way as an equation is in terms of the inequality is like that equal sign. Whatever we do to one side, we have to do to the other, and that's going to let us get our variable by itself. So for this first example right here, let's see. X plus 4 is greater than or equal to 5. How do we get the x by itself? We have to get rid of the plus 4. So to get rid of plus 4, what do we do to both sides? Subtract 4. Minus 4 from both sides. What do we bring down? The x. We bring down this greater than or equal to this time. And what is 5 minus 4? 1. So that is the solution to this particular equation or inequality. If x plus 4 has to be greater than or equal to 5, the solution is that x can be anything that is greater than or equal to 1. So it can be 1, it can be 2, it can be 3. We could plug in any of those things for x, and this would work. So are we able to actually do a check the same way we've been doing? Can I plug in just 1 to the check? Well, I could, but I'd also have to test out, well, 2, test out 3, test out 4, test out everything that's bigger than 1. So we're not going to do that. We're not going to test an infinite number of possible solutions for this. But we are going to show what it looks like on a graph so we can get a sense of what those solutions are. So let's see. How do we graph this? We know our point of reference here is kind of 1. We want x to be everything that is bigger than and equal to, greater than and equal to 1. So I'm going to make my number line. We can put a 2, a 3, we could put a 0. What would come next to the left of this? Negative 1, if I'm counting by whole numbers, integers. And we know that x could also be 1. It could be anything that is greater than or equal to 1. So it's going to go up this way. Okay, greater than or equal to 1. And there is our graph for that. So really, it's just like solving equations, except we've got an inequality in there. Let's try and practice it. How about number 1 down here? Let's get rid of the minus 3 by adding 3 to both sides. We bring down our x. We bring down our less than sign this time. And what is 9 plus 3? 12. So our solution to this particular equation is that x has to be less than 12. It can be anything less than 12. So how would we show that on a graph? Well, let's say 12 is right here. Point of reference, we can make 13 here. We can make, hang on. We've got 14. If we go down here, we've got 11. How about 10? So x is anything that is less than 12. Can it be 12? No. So we do an open circle. Anything that is less than 12. Right there. All right. Number 2. Now, here is where our practice with simplifying and then solving equations comes into play. Because in this case, there's some combining like terms that we can do before we start to solve the equation, right? What can we combine on there? There's some x's, right? If I change this minus x to plus a negative, it's 2x plus negative x is going to be 2 plus negative 1 is just 1, right? 1x or just x. And then there's still a plus 4. So that simplifies the left-hand side. I bring down my greater than or equal to, and I bring down my 5. Now, we can't simplify anymore. So if we can't simplify, then we're ready to solve. We're ready to do something to both sides to get the variable by itself. We need to get rid of the plus 4, so we're going to subtract 4 from both sides. 4 minus 4, bye-bye. So x is greater than or equal to, 5 minus 4 is 1. There is our solution. Let's graph it. Let's get a 1 on the number line. And x is anything bigger than or equal to that. So let's do some more integers. 3, 0, negative 1 maybe. And so it can be equal to 1 or greater than 1. Greater than or equal to 1. Okay. Next one, again, important as we move to number 3 to realize that we need to simplify this before we start doing things to both sides. In this case, I can't just start adding 1 to both sides because that minus 1 is in parentheses. What do we need to do first here to simplify? Yeah, there's a distributive property. We need to distribute that. So I'm just going to change this minus 1 into a plus negative 1 so I don't make any silly negative mistakes. And let's do 2 times x is 2x plus 2 times negative 1 is a negative 2. Bring down my greater than, bring down my 9. And now there's no like terms, so I should be ready to solve it. This looks like a 2-step inequality. I've got to get rid of all adding, subtracting first. So can I get rid of my negative 2? How do I get rid of a negative 2? Bring it up to 0 by adding 2 or subtracting negative 2. Same thing. Negative 2 plus 2, see ya, it's just 0. I bring down 2. X is still greater than 11. Okay. Now at this point, let's see, what are we going to do to both sides? Divide both sides by 2. Get rid of that. We have 11 halves. Okay, for this part, since we're going to want to graph this on a number line, we can go ahead and change this into a decimal when we're dealing with inequalities, as long as it's a terminating decimal. And in this case, what's 11 divided by 2? What's half of 11? It's going to be 5.5. We can do that because we can graph a decimal on a number line. We can handle that. So as we do that, let's put 5.5 here. And then maybe we want to count by tenths, kind of like we did before when we were practicing with decimals. 5.6, 5.7, over here, 5.4. And we know x is greater than 5.5, so it can't be 5.5, but it's everything greater than that. It's all a possibility, so it's going to go to the right. Okay. Let's try number 4. Again, another equation or inequality where we have to simplify this first. We've got 2 parentheses x plus 1. Let's do the distributive property. It's going to be 2x plus 2 this time is greater than 2. I think we just have 2. I think mine says something different than yours. Oh, I know what we need to do. On this one, we decided that we are just going to cross off the x. That was a typo on our part. So let's make that just greater than 2. Okay. In this case, what are we going to have? We're going to subtract 2 from both sides. All right, now we're ready to solve it. And we get down to 2x is greater than 0. Okay. So 2 times x is greater than 0. Well, can we divide both sides by 2 still to get the x by itself? What's 0 divided by 2? Can we do that? Sure. 0 divided by 2 is just 0. So x is going to be greater than 0. So in this case, anything that's greater than 0 would work if we plugged it in for the x. Let's show that on a graph. Here's 0. We can make a quick number line when 0 is on there. X is anything greater than 0, not equal to 0. 0 won't work. But greater than 0, sure. Okay. Let's test that. What if we plugged 0 back in? If we put in a 0, what's 0 plus 1? 1, right? And 2 times 1 would be 2. Is 2 greater than 2? No, that doesn't work. But anything bigger than 0 will make it bigger than 2. It will work. All right, last one on this one. We've got negative 2.2 is greater than x plus 1.8. All right, so we need to start getting the x by itself. Actually, we can't do anything to simplify it, can we? It's already simplified. Let's just solve it. To get rid of plus 1.8, let's subtract 1.8 from both sides. See ya. Bring down what we have left. X, we bring down our symbol. And then negative 2.2 minus another 1.8, 2, 3, I think that's going to get us to negative 4. So this is saying that negative 4 is greater than x. This is the first one we've had where the x was over here, right? Think about that. Negative 4 has to be bigger than x. So doesn't that really mean that x itself has to be less than negative 4? Could I rewrite this as x is less than negative 4? If negative 4 has to be bigger than x, x better be smaller than it, right? X better be smaller than negative 4. So sometimes it's easier to think of it that way, think of it as the x being first so that we can graph it. So if we've got a negative 4, and we're going to do some numbers on the number line, be careful because the next bigger one than negative 4 is negative 3, right? Negative 2, negative 1 going towards 0. Smaller than that would be things like negative 5, negative 6. So if x is going to be less than negative 4, it can't be negative 4. It could be anything that's smaller than it, though, and it will work in that equation. Okay, we're going to do some practice on our own.